All right, now we are going to find the limits analytically, or another way of saying that is we're going to find the limits of functions that are given. Let's start with part A. Every time we want to try to see if direct substitution works, as long as it's the x value is in the domain. And so what I think in my head right here is the domain I know is all numbers except x cannot equal 0 just by looking at that denominator right there. And I cross that and check that with what x is approaching, and it's e, and I know that they clearly if you plug in e, it's not gonna it's gonna be continuous at that moment. So what that means is I can use direct substitution. So if I would just erase those arrows, so that means I can directly substitute and say ln of e equals 2e. I know ln of e is 1, and 2 times e is just 2e. We can leave it like that. We're done. Next problem. B. Let's see if we can use direct substitution in this one. I look at my function here, and I think, what's the domain? And I know it's just a polynomial quadratic function, so it's all real numbers. There's no discontinuity, or it's continuous on its entire domain, so that means I can do direct substitution. It's fair game. So I'm just going to plug in 2/5, 5 squared plus 2 times 5, and that becomes 2/5 times 25 plus 10, which ends up becoming 20. There we go. All set, done. Okay, let's do C. To help us prepare, I'm going to get the unit circle ready. It looks like we're plugging pi, and I know pi is way over here, and the coordinate pair is -1, 0. So it's going to help us get ready. So I know that for sine, cosine functions, the domain is all real numbers as well. So we can use direct substitution. When I plug this in, I'm going to get sine squared pi plus 2 cosine pi. Now, before we continue in figuring what's happening next, is I want to talk about this this squared right there, this sine squared pi. So some people may be new to this notation, but essentially what I'm going to write on the side here is that whenever we have sine squared of theta, that's equivalent to saying sine of theta squared. It means the exact same thing. So what I'm going to do is I'm going to rewrite this part, the sine squared pi, as sine of pi, all of it squared. I'm just going to rewrite it like that. Help us see. Okay, so now I'm going to use the unit circle to find sine of pi. I know that my x values give me cosine and my y values give me sine. So what this ends up becoming is sine of pi is 0, so it's just 0 squared plus 2 times, and cosine is -1. So the answer ends up becoming -2. All right, so D. Let's just skip that